Hello, everyone, and welcome to the State of IoT Connectivity webinar series by Monogoto. My name is Asaf Sela, and I'm the marketing manager at Monogoto. Today, we will present to you our API-driven infrastructure as a service for IoT connectivity and some of our advanced features which can really help you to create true competitive advantage with a greater value for your IoT product. Our host for today is Mr. Maor Efrati, our co-founder and CTO. Maor has 25 years experience in building cellular networks, cloud, and internet applications. Our guest speaker for today is Mr. Oli Smink, the co-founder and CEO for Sodak. A bit about Sodak. Sodak design and build IoT solution in projects for large corporates, and they manufacture product for companies who wants to deploy tracking and sensing devices in their logistic chain. Lastly, I would like to finish with few administrative guidelines for the webinar. We have a 1-hour session in total, when the last 15 minutes will be reserved for Q&A session. Nevertheless, you can feel free to ask questions during the session in the chat window. And don't worry, if in any case we missed any questions, we will contact you after the webinar. And now, without further ado, I will hand the mic to Maor. Enjoy the webinar. Maor, just you need to unmute yourself.
Nothing like starting a webinar on mute. I think this is a good start for our webinar. So guys, I'm very excited to be here. This was a hell of a year. Thank you for joining our webinar. This is going to be a series of webinars that we are going to operate in the next few months. We are going to talk about IoT. In today's session, we want to talk about the state of IoT connectivity. We're going to compare IoT to the cloud. In the future webinars, we want to talk to you about low power use cases. We want to talk about 5G, private networks, and many more good things. We are big believers in IoT. We are big believers that the IoT innovation and the revolution is happening. And we are here to support it, and this is the DNA that we are building at Monogoto. So we want to learn, and when we build Monogoto, we learn a lot, and we learn from the cloud. I don't know if you know these jokes, we like it here. We don't see clouds anymore, and we are not flying, so we don't see clouds from close. So the nearest for us in clouds is Linux servers. But we do believe that the cloud that I think changed most of our life had a tremendous impact on many applications. And Asaf said that I have 25 years experience in telco, and it's true. And we see in the industry today, a company like Dropbox, if they want to build a solution, they don't need to worry about servers. They don't need to worry about co-location. They don't need to worry about how much money they need to buy in storage in order for their product to be perfect. In the cloud, everything is already solved. A company can start small. A company can use an API to change a hard drive. I remember the days that we used to fly somewhere across the Atlantic just to upgrade our system. Today, the cloud is an enablement for many startups and use cases. And a lot is thanks for the fact that the cloud really lowered the barrier for new solutions, lowered the barrier for people to come with nice ideas. And the cloud is solving the problems. The clouds can allow you to start small. The cloud allow you to scale, solve regulation, and most importantly, fail fast. Today, if I have an idea of the next Dropbox, I don't need to invest hundreds of thousands of dollars in it. Few $100 infrastructure as a service is more than enough to build a cloud solution. This is all thanks to AWS, thanks to Amazon, Azure, and Google that build great infrastructure as a service for cloud. And this is an amazing habitat for a lot of innovation. We think that this is the way IoT should go. If AWS in the past was just a virtual machine, but then to solve problems for people, to really allow a developer to come with an amazing idea like Dropbox and execute it fast and focus in the product, AWS had to offer much more than just virtual machine. It's need to take care of your web balancers and on security and on storage and many problems that on the normal day-to-day of a developer will take lots of time to innovate, to execute. This is all evolved in the last 20 years, maybe a little bit less. And today developers are, sometimes we say that developers are lazy because developers don't need to write everything from scratch in C. Developers don't need to write everything from scratch anymore in any language that is complicated. Developers today get the building blocks with SDKs, they get APIs, they get webhooks to create event-driven architecture. And if my server is overloaded, that's not a problem. I will get an alert that the server is overloaded, and I will issue another instance, and the load problem is solved. This is all developer experience. If we remember the days of user experience and UI and UX, now there are new ways, developer experience, to give developers the way to innovate inside a platform. We want to take this approach. We are taking this approach already, and we are going to continue to take this approach on IoT. So the developer experience, the way for us to allow people to come with ideas that need connectivity and need automation with APIs, need a webhook to get events from the platform and trigger action based on the event, or maybe an integration that is available in the cloud and not really available on IoT. Think about the mere fact that I want to know when my SIM card got disconnected or there is degradation of service. But I don't want to write complicated stories around it. I want to send a notification to PagerDuty, and PagerDuty can make a telephone call, can play a recording, can sequence some dialing or procedures, allowing application to talk to, allowing the cloud to talk to other applications. This is all stuff that developers take for granted in the cloud, but not really expect to get it on the connectivity. So the big question is, everybody knows so many devices are coming, so many IoT stories, and every day we hear about different numbers of how many IoT devices are going to be out there. We are a big believer that the next revolution is IoT. Any device today is adding the word smart next to it. And smart devices are great because smart devices can talk to the cloud, smart devices can get software from remote, smart devices can get better user experience, but we don't really know what's going to be the killer app on IoT. Like nobody really knew that Netflix and Shazam and Airbnb will be the killer apps for cloud. But we do know that for the innovation to come, we do know that for people to be able to execute, they need a platform that they can develop fast, they can fail fast, and they can benefit from all the infrastructure that is already given to them so they can focus only on the product. So basically, this is what we are doing in Monogoto. Monogoto is a cloud core, and our cloud core is designed for IoT. Designed for IoT not only on the public network, we are big believer also on private network. We think that the world is getting really not black and white. So maybe my IoT can be sometimes on private network, maybe my IoT device can be sometimes on public network, or vice versa. But we do know that more and more IoT use cases need a place to innovate, need a place that is an infrastructure as a service with best practices of the cloud. It will allow me to use an API and trigger commands to the network. It will allow me to get notification from the network, and it will allow me to integrate my solution to third parties. Like I said before, if I want to get an alarm when something happened in the network, developer used to get the alarm in PagerDuty. Developer used to get the alarm in Slack. And this is the ecosystem that we build around our cloud, the ecosystem of connected apps, the ecosystem of APIs and self-service. Because we are a cloud, we are not married to one vertical. We are not married to one use case. A cloud solution can serve multiple different verticals, and basically we are agnostic to the vertical. We see some traction in one vertical, in few verticals like we have here in the slides, but this is not limiting the reach of what we can offer. We choose to become a connectivity platform. We choose to bring APIs and developer experience to this platform, and we are welcome any use case. And if you guys, your use case is going to be the next killer app, and it's not in this list of verticals, we will be happy to host it, absolutely. And we'll be happy to even prototype it. So Monogoto look at the cloud exactly, at the IoT exactly as the cloud evolved. If in the first slide, we showed a picture of multiple server versus cloud, the story is literally the same. Today, if somebody have a genius idea for some IoT app, but he needs connectivity, and he needs it to be global, and he needs it to be with automation, and he needs to comply to regulation, and he needs all kinds of capabilities from the network, there is a question. Do I need to go and make a large commitment to an operator in order for the operator start and take me to the process of opening for me all those capabilities? Or maybe I have a better way to consume it. Maybe I can take single SIM card from Monogoto, and with this single SIM card, I can start small, and I can use API, any APIs to automate the service, APIs to make it a robust, API to comply, you can use the cloud to comply to regulation, and of course, this solution can be global for me. So the best practices from cloud are going to IoT. What we did now, we chose to take few examples, and on those examples, we will just give a glimpse of the capabilities that our network provides, and we'll take some examples of how it can save time for developers. Some of it already being used by even the company here that we are hosting with us, Sodak, some of it by other companies that we work with. So the first example, very trivial, is an API section that we have called networking, and the example is a VPN. There are many reasons for an IoT developer to have a VPN to his backend. Some of them is for better security. I can stay on private IP end-to-end. Some of them is maybe easier authentication. Instead of inventing an authentication mechanism, I can authenticate the device with an IP address. Maybe a combination of IP address and certificate. We can also allow you to hold the certificate in the SIM cards, but the ability for a developer to treat a private network as his own network represents a big benefit. But what's the problem? You don't want to wait a few months to get a VPN up and running. You don't want to make a big commitment for a provider to open a VPN for you. The ability to use an API request, and this API request or a few clicks on the portal will open a VPN to your backend. This is all capabilities that allow a developer to save time and have a more effective use of his money and time on developing the product. Another example is a ping to a device. As we as the technical people in this room knows, a device that is going out to the internet is going through NAT. And NAT is not always, in this example here, we are showing VPN, but this slide is also accurate if I'm doing NAT and going towards the internet. So when I'm going out to the internet with my device, I might not be able to come back. Now there is a question, do I need to program complicated scenarios in my IoT device to make sure that the tunnel will always be open and I will always be able to communicate back to my device? Or maybe there is a simpler way to solve the problem. Maybe I can use an API request that just to ping the device every half an hour, and then the tunnel will stay open. The ability for a platform like us to solve problems that alternatively will cost the developer many days or hours of development, this is the examples how we think innovation can come to IoT. Pinging a device, by the way, if we'll talk later on to Sodak, they took it to the next level and they can do an EDRX ping. They are doing this to the radio, so they can even save the IP tunnel and do it with our APIs over the radio. Another use case that we like and we see good traction is location. We met developers that had a need for an IoT device, but they don't want to invest too much money on the device, so there's no need to have a GPS in the device. So how can I get location if I don't have a GPS in the device? I will use the cell ID. Maybe I don't really need the 7-meter accurate location for the device. Maybe a cell ID that's showing me in which city the device is good enough. So when I'm using cell ID, I have two options. Either I will write code on my IoT device, and this code will report the cell ID back to my backend, or maybe I can get it with an API from Monogoto. So an API to get a cell ID, but maybe even more. Maybe when the device is moving between two different cells, I want to get a webhook and I want to know that the device moved. So now I can have, I don't know, a bin somewhere in London, and if somebody, God forbid, stole the bin and move it to some other place, I will get a notification, even if I don't have a GPS on the device, or even I don't have a motion sensor in the device, just because of the fact that the cell ID changed. This is all to give examples how the infrastructure can become your benefit, how the infrastructure can help you save time and focus on your product. Another example, guys, not too many, 2 or 3 or 5 more, and that's it, maybe 6. SMS, no, I'm joking, 2 more. SMS. So sometimes, traditionally, devices had an SMS slot, and maybe the old devices that are out there need still to receive an SMS. But instead of receiving an SMS on a let's say, old-fashioned, I need to know the number of the device, we can use an SMS with an API. An SMS with an API is more secure. And I want to tell you a secret, is even for free, because incoming SMS is for free in cellular. So when I'm sending an SMS to the device, I can wake him up if I lost data. I can tell him to report something if I don't have data on the device, or I can even reconfigure the device in some way. Last thing, almost last thing that we are very excited about is the ability to integrate the cloud to other services. And by us integrating the cloud to other services, I can connect my cloud now to Slack, or connect my cloud to PagerDuty. And then if a device went down or didn't report or did too many megabytes or create too many events, and I want to get a report, I will be able to get it, but I will be able to get it in channels that I used to get from my cloud environment. And this is, for us, very exciting, because not only we are opening our cloud for APIs and we are opening our cloud to webhook, we are also allowing the customer to integrate the cloud to other SaaS. It can be integration to the CRM, or it can be integration to notification services that are very popular on cloud. This is also nice in the transition now to SODAC. So this is a request that came from our partner SODAC. And this is a nice example of how a Monogoto is going to help developer even more. So most people that build an IoT solution are building it using MQTT. But what's the problem? MQTT is chatty, and MQTT is not really helping me to save bandwidth and save power. And eventually, I want to have a sensor that will last for a few years, and I want the sensor to transmit less, because when the sensor will transmit less, I will also pay less. So what's the solution? The solution that two options, either to develop from scratch a mechanism that converts UDP to MQTT, or use a service, and this is not live in Monogoto, but will be live soon, or use a third-party service that is coming with Monogoto Cloud that will allow to convert MQTT, to convert UDP to MQTT. And then the developer don't need to work hard. He can store his MQTT certificate in the cloud and just allow the device to send a simple UDP packet, and whole translation to MQTT will happen in the background. So this is all glimpse of capabilities that we have in Monogoto. We have more than 400 different APIs at the moment and counting. And we are a big believer in giving more and more services and more best practices for developers, so the developers will focus on IoT. And with this slide, I will pass now to Oli to talk about SODAC. SODAC are great partners for us. We learned a lot from them also. They are amazing in building IoT projects, especially on when you need low power and really to perfect the IoT solution. And in the end, guys, we'll have time for question and answer. Thank you very much for listening, and looking forward to the question and answer in the end. Oli?
Yes, I will just start my video up here. Thank you so much for the great introduction from you, Maur, and also for the introduction in the beginning, Asaf. I will try to get the video up. It's just needs to have the permission for that.
1 second.
So while we're setting this up, I'll get started to introduce SODAC a little bit further. So SODAC in the world of IoT is... yes, here we are. So I hope you can see a little bit of a world of IoT here behind me. Yeah, referring back to what Maur said before, we actually put a few clouds into the world of IoT here. So within the domain of IoT, there is a huge growth in number of devices of all sorts of use cases. We hope that as a hardware company, we can find one or more of those killer apps. But in the process of creating a killer app, for us, it's really important as well to focus on the sustainability of creating new devices. So what's the purpose of making devices that connect to the internet? It is to add value either to consumers or to businesses. And so in the process of adding this value, we want to make sure that we can create devices that last and to create devices that have a minimal negative impact on the environment. Because of course, while we're supporting businesses and consumers, we also want to support the environment that we live in and operate in. So a few of the things we really focus on here is to use low power technologies. So SODAC is really an expert in using as little power as possible to make a certain application work. And so what you will see with using as little energy as possible is you need to use clever tricks in how you process things, how you communicate. And so when you use these clever tricks, some of them I'll get to in a moment, you're able to use so little power that you can basically sleep as much as possible and only really for example, collect data in the moments that you require it. So collecting a temperature reading or so, and only send that information when really required. And when doing this, you can save costs, and also you can start to use features such as energy harvesting. So a few of the applications that we make, such as these trailer trackers for trucks, use solar panels. And in order to use solar panels and this energy harvesting technique, you need to use less energy than that you can harvest with the solar panel. Now, within this domain of IoT, you see often that there are battery-powered solutions. What we try to focus on is to reduce the number of batteries we use. We actually have a vision for an Internet of Things without batteries. So either using only alternatives such as supercapacitors, or using batteries that are much more easily recyclable. Some other forms of energy harvesting are like solar, kinetic, or heat energy. So I think what's also important in the introduction here is to share that the low power aspect really links with Monogoto too, because in some of these tricks, you need to make some unique modifications to how you use the networks. And there are many things that are flexible within the regulations within cellular IoT. And so with a partner like Monogoto that's directly linked to different cellular operators, we can really make use of those techniques. So within SODAC, we actually have two components of the business. One is that we do engineering. So as you can see behind me, there are many different applications that we have built. One of the coolest applications we have built is actually a smart label, which is a completely flat electronics device, which uses a flat battery. This flat battery is paper thin, and the electronics are printed on a flexible PCB, making one of the lowest cost and least negatively impactful IoT devices in the world. This is just one of the projects we do for logistics. We have many customers around the world that employ us to create different products for them. And also in the process of that, we create our own products. So one of our, what we believe is really a killer app is solar powered asset tracking. So you can see here, really small solar panel, a device that can be connected very easily to an asset and can monitor that asset without ever having to be replaced. So it charges itself. There will be there is a version basically without any batteries that can permanently work for multitude of years, let's say 10 years. And this means that the waste is really minimized. And so you see on the right a few different products that we have, ranging from air quality monitoring. And this is a project where we worked very closely with Monogoto. This project we actually needed to run in different countries. So we needed a roaming SIM card on the LTE network. And because we have different applications, we need to also group the different connectivity sets. So different sets of SIM cards. We've been able to get, for example, chip SIMs. So little, not plastic SIMs, but the soldered SIMs. And so that makes us much more scalable in production. And then we also have a project in the building and construction space, which is the one you see on the right, which is also a solar powered device. But this one uses much more data. So it does 3D measurements of position with a sub-centimeter accuracy. And this kind of product requires much more data. And this is also where Monogoto is a really good partner for us, because also for high volumes of data, there's really good value for money. Within our engineering domain, there's one project that I want to focus on a little bit more. So what's really cool with Monogoto is also that we can make use of certain software features before they are even available publicly. Now we developed a pet tracker, and Maur mentioned it briefly earlier, where we used a feature to ping the device, not only via SMS, which is a classical way to ping, but also via a feature called EDRX. And EDRX stands for Extended Discontinuous Receive. And this basically opens up the channel to receive an incoming message for example, 1 second. And within that window, the network will actually tell the device to wake up, meaning the transmission of the device doesn't have to be switched on, saving a lot of power, and only receiving, which requires much less power to activate the antenna. In this project, we actually worked in the US and did a pilot with 50 devices. Before AT&T was ready to have this service on their network, we were actually able already to test this with Monogoto because of their much more advanced, let's say, capabilities and much more flexibility. So we were extremely fast to go to market, and it's easy to try new features. What was also really good in this project, and I can grab it here, is that inside this device, you can see just a prototype here. When I shake it, there's a little magnetic element in there that turns in circles. And so that generates kinetic energy. And so we were able to create a solution that, because of this low power feature, requires so little energy that when placed on a pet, it would be continuously charging while moving. And when that pet is, for example, lost in an application, the owner could ping the device and the device would start reporting the location of the pet. Just have another example of a solar powered ear tag for cattle that we also developed, which is also one of our key projects. So my last slide here is a little bit about another collaboration we did with Monogoto. Since the beginning, Sodec has been very involved with the developer community. So we believe that ourselves, we really want to find the killer app. We really want to create solutions that have a positive impact. But at the same time, there are also many developers out there that have really great ideas and can build solutions themselves. So what we've been doing is supplying them with a standard printed circuit board with a modem for cellular communication, for example, GPS, and some sensors such as an accelerometer, a temperature sensor. These type of developer boards, we have been with Monogoto SIM cards offering so standard out of the box. What's really great here is that we can offer one SIM card very easily, not needing a huge contract from a telco. When we, for example, want a secure connection, we can, with a few clicks, set up a low-cost VPN instead of having to go into a contract that takes months to set up and thousands of euros or dollars with a network operator. And also there's roaming capabilities available and all the APIs we can use for pinging. And we can actually enable developers to quickly use many of the features we use as well. What has been really useful as well is when a customer purchases this set, so our board and Monogoto's connectivity, when they run out of data, which comes at a really good price with Monogoto, they are able to, through a very simple web page, just re-upload a new credit to that SIM card, and they can continue to use it. So across the board, we're really happy with the collaboration we have with Monogoto. And if there are any use cases that any of the attendees here are interested in developing, please reach out to us. We're happy to support. We have a lot of experience with over 200 projects already, and we're still going to continue to try to have a positive impact. So that's it from my side here. Thank you.
Thank you very much, Oli. Great stuff, man. Thank you, Maor and Oli, for your wonderful presentations. Now let's start the Q&A session. We have several questions from the crowd. I will start with questions for Maor. The first one, do you support 2G, 3G, 4G, and also LTE CAT-M?
1 second, guys. Now I need permission to open the video. In the next webinar, we'll find how to open multiple videos in Zoom. Yes, we support we support all the technology, even 5G, but 5G and roaming is a little bit complicated. So if somebody have a private network use case that they need 5G, we will be happy to support that also. Some networks are putting to sleep the 2G. So if you are a young developer, but not young developer, but if it's a new IoT product that don't necessarily need to trust 2G. I wouldn't bet on 2G. I would start immediately with CAT-M. But yes, we support all technologies.
Great. The next question is, you have a lot of advanced features that we don't need right now. Is it still relevant for us?
I guess this is for me and not for Oli.
Yes.
Our vision is that probably you don't need it now. You might need it when you scale. Probably you didn't think that you need it, and you might need a VPN later or any other feature. And it's like in Amazon. You come to get a virtual machine, and suddenly you see that you get a web balancer, or suddenly you see you get the storage also, or you get some queue, and it makes your life easier. So absolutely not a problem to come only for the connectivity, but we are sure that along the way, customers will always find more and more capabilities that are saving time, and we can cover them also.
Okay, the next question is for Oli, for SODAC. What would an engineering project for SODAC looks like?
It depends a little bit on exactly what kind of application is required. So it can range from using standard hardware that we have and developing custom software features. This would be a relatively small engineering project. And that would take us, let's say, from a month onwards to develop. And we would engage by working with our team. So we have an assigned project manager, we have an assigned software engineer, and along with the customer, we would define specifications and work it out. And this could also be a bit bigger. So we could potentially have a hardware change requirement, or the requirement to build something from scratch, and also make an enclosure for it. And these would be bigger projects that could take up to 1.5 years in some cases.
Okay, the next one is for Monogoto. We are looking to deploy a private LTE, but at the same time on public IoT. The first question is, do you support private LTE? And the next one is, will your API support interoperability between the private and public networks?
This is a question that I think also Oli might have something to say. So from the network side, we support public and private. From the network side, we believe that the mix of private and public network is going to be a big part in the next killer app. So the answer for this question is absolutely yes from the network side. The reason I said that it might be relevant also for Oli to comment is that now there is a question if the modem, and it's also depending the country that we do the private LTE, if the modem is capable of coming to the private network and the public network, or maybe you need to have two modems. We do work with SODAC at the moment for some sort of, we are testing the market of a need of trackers that will also work with private network in the US, which is on the CBRS band.
So maybe I can just add there that for some projects, let's say there's an offshore airport being built where vehicles must be tracked, or sand that's sinking must be monitored. That's a very interesting place to work with private networks. There's many other cases. And so we are actually really investigating and opening up that use case from the device side. There's more and more support coming from the module manufacturers like U-Blocks or Nordic Semiconductor that we use. And so in those different modems, the firmware needs to support it. So either existing network frequencies need to be supplied from the network side, and then it works out of the box. And if there's unique, let's say, frequencies being used, then we would need to see if that is fitting with the modem that we use.
Okay. Yes, more?
Yeah, I see here a question. if we can set priority for the technology, 2G, 3G, 4G. So yes, we can, and we can do it from the network side, or we can do it from the SIM side. And this is, again, the parts of the API to do steering, so you can also help the device or the modem to decide to which technology to connect from the network, or really from configuration that is stored on the SIM card. And there is a question that is also a little bit similar about using Monogoto in Africa, and the networks in Africa are complicated. And how do we plan to allow switching between systems? And here it's another capability that we are working on and will be introduced soon, is the ability to have multi-different identities from multi-different operators, and with an API to be able to switch between identities.
Okay, the next one goes for Sodak. What is the typical data usage of a solution, and what are the costs related to the connectivity?
So it depends on the package that's selected also and the product used. So for example, a continuously communicating device for air quality can maybe use somewhere between 10 and 20 megabytes per month of data, while a simple asset tracker can maybe use just less than 2 megabytes per month. And so prices for that can really be in the tens of cents per month for the lowest data consumption use cases.
I would add here that to innovate the use cases, you need to also be able to have a price that can justify the product. Sometimes to have these capabilities of a network like Monogoto is not only about the APIs, it's also the business model. If we look at Amazon selling servers on 20 cents per hour, so new business model that allow and justify the solutions are very important for the next killer app.
The next one more is when 5G will be introduced, and what are the benefits with Monogoto?
We believe that 5G is not a faster 4G. We believe that 5G will be helping organization. We believe that the 5G will be helping campuses, stadiums to have multiple different services. The benefit now to use Monogoto is that it's easier to prototype with us rather than build a network with hundreds of thousands of dollars. The benefit in the future when operators will offer 5G slicing will be that the 5G slicing will be for very expensive price, or companies that can pay a lot, and companies like Monogoto can sell it for the lower usage. But maybe we'll park this question for the 5G webinar that we'll do, and we would love to talk more about how we see the evolution of 5G, or the involvement of 5G in the near future.
The last question I have is for Sodak. What unique solutions are possible for Sodak and Monogoto to create?
So what is really unique about the combination here is that we can create something that has connectivity almost everywhere. So we can combine these private networks with public networks, or private LTE with public LTE, and place networks where there is currently none available, and have another form of backhaul, such as satellite or whatever is useful. And also, what makes our collaboration really unique is that we can try out new things that are currently not being done in the market. And so when we look at, for example, making a solar-powered solution, we can make sure that it's really functioning within the power constraints that we have. Yeah.
Thank you, Oli. Okay, everyone, thank you for.
One second, Asaf. I see
Yeah.
2 more questions. I will answer them quickly just so we didn't leave anything hanging. So there's one question here about if can get more information about EDRX pet tracker. We would love to share information. The email is
The
here
next
on
slide
the
shows
next slide. We'll show it. And the last one about LoRa. LoRa is not cellular, so it's not part of the Monogoto network, but it is definitely a technology that might help other use cases. And I think Sodak have some products around LoRa, but I think we have time for that.
We still have a few minutes, yeah.
So Oli, if you want to say one word about LoRa.
So I think in, for example, the wildlife tracking applications that we have, we use LoRa because there's no connectivity in certain wildlife parks, and we want to track animal behavior with different research institutes. There we've actually worked with Monogoto to provide connectivity as a backhaul. So the LoRa device is communicating to a LoRa gateway, and then it's being forwarded to the cellular network by, let's say, 4G. And because Monogoto's SIM card is then in a router that's on a really high mountain, it has connectivity to pass that data on.
Perfect.
Thank you for the answer, Oli. Okay, guys, thank you everyone for participating in this first session of the State of IoT Connectivity as part of our webinar series. I really hope that this session was educational for you. We would like to get your feedback on everything. So if you have any thoughts or ideas, please feel free to contact us in the email listed here. And make sure to check our website and also subscribe to our social media channels. And then you will get the latest update from Monogoto. Okay, guys, so thank you again, and we will see you in the next webinar.
Thank you, guys.
Thank you so much.